Hello students, welcome to STUDIFYSUCCESS. I hope you all are doing great. This is second lecture of circles. So today we will cover some questions and theorem based on what we have done in previous class. First theorem is the perpendicular from the center of a circle to a chord bisects the chord. So this theorem is the converse of the theorem which we have done in the last class. So the theorem was that line drawn from the center of a circle to bisect a chord is perpendicular to the chord. So we have done this question in last class, and now we are supposed to do the converse of this theorem. In this theorem, it is given to us that OM is a bisector of AB and we have to prove that it is perpendicular to AB. But now, in converse part, we have to prove. So it is given to us that OM is a perpendicular to AB, and we have to prove that this bisects AB. So the perpendicular from the center of a circle to a chord bisects the chord. So bisector का मतलब होता है that it divide into two equal parts. So if M is a bisector of AB, that means AM equals to MB. Given to us OMA equals to OMB equals to 90 degree, and we have to prove AM equals to BM. So we will consider two triangles OAM and OBM. So here OA equals to OB because it is both of them are radii of the same circle, so these are equal. So OA equals to OB. Secondly, OMA equals to OMB because these are 90-degree perpendicular, which is given to us. And thirdly, OM equals to OM common. So these two triangles, OAM and OMB, OAM and OBM are congruent. So by CPC we can say AM equals to BM. So hence if these are equal, AM equals to BM, that implies that OM is the bisector of AB. Now we will move to the result which will be useful in solving the questions. So the result says that equal chords of a circle are equidistant from the center. So अगर कोई सर्कल है जिसमें दो chords equal है, so like here I have considered PQ and RS. So PQ and RS are equal in length. Then their distance from the center will also equal according to this result. So अगर किसी question में given है कि PQ equals to RS, then their distance from center, that is OL equals to OM. Also, the converse of this result is also true. That is, if chords are equidistant from the center of a circle, then they are equal in length. So, in case it is given to us that the chords are equidistant from the center, that is OL equals to OM, then we can say that PQ will also equals to RS. So, these results are very helpful when we are solving the questions. Next result is a circle can have infinitely many chords, right? But when we draw so many chords of a circle, we will observe that the longer chord is nearer to the center than the smaller chord. अगर कोई सर्कल आपने ड्रॉ करा उसमें आपने बहुत सारे chords को ड्रॉ करा तो आप ये ऑब्जर्व करोगे कि जिस chord की लेंथ ज़्यादा बड़ी होगी वो सेंटर के नियरर होगा एज कम्पेयर टू दी स्मॉलर chord. Now we will move to the first question. So if a line intersects two concentric circles, then we have to prove AB equals to CD. So first thing is what is concentric circle? So two circles are said to be concentric if their center is same, right? So here O is the center of this smaller circle as well as bigger circle. So these two circles have the same center, so these are called concentric circles. So it is given if a line intersects two concentric circles. That is, this line intersects both the circles with center O at A, B, C, and D. And we have to prove AB equals to CD. Okay, so how we will proceed is firstly we will draw a perpendicular from a center to this chord. That is, OM is perpendicular to this line. That means OM is bisecting AB. So if OM is bisecting AD, then this means AM equals to MD. We will mark this as first equation. Secondly, OM also bisecting the length BC. So this means BM equals to MC. So we will mark it as 2. So if you subtract equation 2 from first, you will get AM minus BM. So here AM minus BM will give you AB. Similarly, MD minus MC will give you CD. So we have proved that AB equals to CD. So now we will move to uh, next theorem, which is that the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So यहाँ पे PQ is our arc and it forms the subtend two angles. First is CEM, which is the angle subtended by arc PQ at center, and secondly CAQ. So this is another angle which is subtended by PQ and circumference A. So according to this theorem, the angle CAQ is half of CBQ because the angle extended by the arc at center is double of the angle extended at any part of the circle. Next theorem is angle in the same segment of a circle are equal. So if you see in this figure, CAQ and CPQ, these are two different segments, right? So here CAQ and CPQ, these two angles are equal because they are in same segment. Now we will move to another question. If you see key points on a circle with center O, such that DOP equals to 30 degrees, this angle is 30 degrees, and AOB is 60 degrees. And if D is a point on the circle other than arc ABC, we have to find ABC की length as जो है what we will give the value of this angle. So it is given to us AOC, which is formed by angle COB plus BOC. So AOC equals to 60 degree plus 30 degree, right? This whole angle is made up of these two angles, 60 and 30. So AOC will be 90 degree. We have learned the theorem here that angles extended by arc at the center is double the angles extended by its any points on the remaining part of the circle. By using that theorem, we can say ABC will be half of the angle which is subtended at the center. So ABC is half of AOC. So AOC value is 90 degrees. So ABC value will be half of 90 degrees, that is 45 degrees. So today this is all about the class. If you find the class useful and want to download